Okay. So 5.3, the main thing I want you to know is what does cosine and sine look like as a graph? And giving this standard general form, capital A sine of omega x and y equal to capital A cosine of omega x. Make sure you know how to find the amplitude, and this is how you find it. The amplitude, or I should say, yeah, the amplitude of both sine and cosine is the absolute value of A. Number 2, they both have a period of 2 pi divided by omega. Number 3, they complete one period, and we'll talk about that in a second, I should say, 0 to 2 pi divided by omega. So that's one cycle for both of these. Now, if you have a more complicated version of them, so A sine of omega x minus B. Hold on a sec. Actually, the omega should be outside. Omega parentheses x minus B. And y is equal to A cosine of omega times x minus B. So it's almost the same. Omega is still the period. A is still the amplitude. This B is now going to be the horizontal shift. So for these have a horizontal shift of B. They complete a period on B to B plus 2 pi over omega. Okay. We'll talk about all of this in just a moment. Periodic property for sine and cosine. So both functions are periodic, meaning they just repeat themselves forever to infinity and negative infinity. They just keep repeating. So they have the property sine of x plus 2 pi becomes sine again because it's just itself, right? So you just shift it and it ends up being the same thing. Same thing for cosine. If you have x plus 2 pi, it shifts to cosine. All right, so let's do an example and talk about all this stuff. Okay. So your homework will start off with stuff like this. So find the amplitude and period of something, some function y equal to 4 cosine 3x. So the amplitude, and I'll show you what that looks like in just a moment, is the absolute value of 4, which is 4. Period will be 2 pi divided by the omega. So whatever number is on the x, that's what you divide by. That's what the formula is saying here. So since every sine and cosine repeats itself every 2 pi, this omega will basically speed it up. So the period will be shortened by that amount. So think about it, right? If I put a 2 in here, then it's going twice as fast. So that means that this would finish half the distance, right? So that's why the period would be divided by 2 if it was 2. But in this case, it's 3 times as fast. So it would be, the period would be divided by 3 from the original. Does that make sense? Now, I'll show you just a moment what that looks like. So we'll look at the original sign. I'm going to mark the 2 pi section so you can see. So here's 0. Here's 2 pi, right? So see how it starts at the bottom, goes up, back down, and then starts over. So it's periodic, it just keeps doing that for forever. Now, if you were to double this omega piece, I just put a 2 in there. I'm going to turn the red one off. Notice how it starts over halfway through, right? So now it's repeating itself twice as fast at this mark. Right here, see? Goes up, down. So now in half the distance, it started over. Versus the other guy, it started over at 2 pi. Okay, so that's what these formulas are saying, basically. The original goes from 0 to 2 pi because there's no number on there, it's just a 1. That's the first one I showed you, the red one. But if I put a 2 in there, well, then this will be shortened by a factor of 2. This will divide by 2. That's all we're saying. So the main thing I need you to know from this section is, what does sine and cosine look like? Just the basic graphs. Can you find an amplitude? I asked for it. Can you give me the period? Yeah.
Is this the one where it's like the amplitude is like how this is the distance between one peak to the next peak? Is that like what this is? And then the other one is like the distance of like the wave from the peaks, or
Yeah, let's just talk
is that
about
what
that.
it is?
Yeah, let's talk about amplitude. So the height of the peak, the red one, the highest that it goes is up to 1. The lowest it goes is -1. So since there's an invisible 1 in front of sine, that's your amplitude. The highest it goes is to 1 and 1. Now, if I had 2, the highest now is 2 to the -2. So the amp has been amped up by 2. Does that make sense? So the distance of the peaks have increased. So it'd be the distance from 0, I guess, if you want to think of it that way. Let's do one more. So what about this guy? What is the amplitude? Yeah, you would take the absolute value of the -2 would be, in fact, 2. So if it's negative, it's still going to have the same distance. It's just going to be flipped, right? We say when there's negative in front, it always flips it reflects the function. Okay.
So F should always have a positive.
Yeah, so if it's negative, just make it positive. If it's already positive, cool. Just write it down. Now, period. It's always 2 pi divided by whatever's on the x.
Okay.
So what is 2 divided by a half? Yeah, 4 pi, right? Any questions on this idea? You see what amplitude means? Can you?
We just keep it to pi over 2.
Yeah, there's nothing we can do here.
Okay.
Yeah, that's simplified already. Let's do another one. Any more questions on A or B? Is it okay? Example 2. So this time find period, amplitude, and horizontal shift. Okay, so here I wrote this horribly, but period, amplitude, horizontal shift. Given this function here. Okay. Pi over 2. So if you look at the formula, go back there in just a second. Notice how there's the omega is factored out of both of them. You're going to have to factor that 2 here. So if I factor 2 out of both of them, what happens to the pi over 2? Close, opposite. Right, so when you factor, what are you doing, right? You're dividing by 2. So this would become a 4, right? From factoring a 2. So I'm basically forcing a factor that's not really there, which you can do anytime you want, just adjust appropriately. So the 2 becomes 4. So if I multiply it back in, you see that we get a 2x and pi over 2, right? Do you see how it's the same as this?
Is there a step that you skip to get to that? Or like the math that you show how that works?
Kinda. I mean, basically, let's go back to basics, right? If you have these both have a 2 in common. If I factor a 2, you agree that it becomes this, right? So what did I do? I divided both of them by 2. Correct? Now, if I had something like what I have now let's make it exactly the same. If I factor a 2, I need to divide them by 2. Right? That's what happened here. I'm dividing both of these terms by 2. A half divided by 2 is a quarter. Does that make sense? Did you still have a question? Or? Yeah, okay. So it's a little weird because we're factoring something that's not there, but it can be done. Okay. Nothing wrong with that. It's just a little weird. Okay. So now that it's ready, what is the amplitude? Amplitude is 3. Okay. What is the period? 2 pi divided by, what is omega? Right? The number on the x that we factored is your omega piece. So you're going to divide by 2. So the period is actually pi. Does that make sense? The formula said to find your period, you take 2 pi divided by omega. Our omega was 2. Okay. We factor that 2 out in front of the argument. That's what we did here. So this 2 is this 2 here. I'll circle both of them. That makes sense? Okay, what is the horizontal shift? Yeah, it's always the opposite though. It's negative pi 4, so I'm going to choose positive pi 4. Right. So if it was plus, switch.
You don't just say it moves to the right side.
You could. That would not be wrong. That's exactly what happened. Right? Any questions on 2? Does that make sense? So can you find the amplitude? Can you find the period? Can you factor and then find the shift? That's all I asked for. So same question again. Find the period, amplitude, and horizontal shift. Okay. The first thing is factor the, it's again a 2 this time. Factor the 2.
Is this 2 pi over 3?
2 pi thirds, yeah. 2 pi over 3. So factor 2 and we will get x plus, right? So now it's ready. We should be able to answer the questions. What's the amplitude?
3, 4.
What's the period?
2.
2 is the omega, right? We have to be 2 pi divided by 2. And the horizontal shift?
Negative pi over 3.
Yeah, negative. Anyway, any questions on 2 and 3? Does that make sense?
Why is the other down should? Oh, because it's, okay.
Yeah, so it's opposite. Just like when we had the parabolas and stuff. Same thing. Homework is 19 through 49. Already posted 5-1 through 5-4. You have 3 homeworks due Sunday. I added 5-1. I think I already had the 4-5, right? I'm not adding any more because it's too much. So next week will be the rest.
That's 5.4.
This is 5-3. Any questions on 5-3? You guys cool in this page? I move on to 5-4. It's going to be super short. And I'm going to leave the rest of the time for questions on 5-1. It was,
19 to the 49.
yeah, 19 through 49. Okay. This section is literally called more trig functions. The tangent and cotangent. So here are the general ones from the book. A tan of omega x and a cotan. Amplitude is still the same thing. Still the absolute value of A. Period has changed. These repeat every pi over omega. Now cosecant. And secant. Y is equal to A cosecant of omega x. Y is equal to A secant of omega x. Amplitude is still the same. Period is the same as before, the 2 pi over omega.
What is the 3 letters next to the A on the Y? A, C, S, G?
Yeah, CSC, cosecant function. Cosecant of Wx. Okay, periodic properties. Number 1. These are periodic every pi. So if you add pi to the arguments, it's as if you didn't. Start at the beginning. Cotan. Same deal. Since they are reciprocals of each other. Number 3. Cosecant of x plus 2 pi is equal to cosecant x, or these are periodic on the when you do 2 pi. Okay. We're not going to do too many examples here because it's almost the same stuff as before. We just do one. Move on. Find period and amplitude. Y is equal to cotan 3x minus pi over 4. So if you factor the 3, what's going to be inside? Yeah, 512. It was, I mean, if you're having problems imagining that, factoring 3 means divide by 3. When you divide a fraction by 3, you're actually, yeah, multiplying by a third. So pi over 4 times a third would be pi 12. That's a quick side note. I'm sure you're all proposed at fractions, but just in case. This is what's happening in the background, right? Anyway, what's the amplitude? Yeah, it's gonna be 1. There's no number in front, so you assume 1, invisible 1. Okay. Period. Yeah, period. Yeah, there's no number. It's assumed to be 1. Yeah, pi over 3. It's called the formula, right? Your tan and cotan, pi divided by whatever the omega is, that's 3. Any questions on this idea? Yeah, it's very similar to the last section. You're just using these formulas and choosing the amplitude and plugging in the omega. Let's look at the graph, though. Here's what tangent looks like. So notice how it skips. So that happens at every pi over 2, every odd multiple of pi over 2. So pi over 2, 3 pi over 2, 5 pi, all the odd ones, not the even. Because if you remember, if you watch the video, tangent is defined to be sine over cosine, right? Let me show you. Oh, so this is the same graph, right? Because they are this thing. That's the definition of tangent. You're just dividing the sine and cosine, which means we're dividing. We have potential for division by 0. So cosine on the unit circle I sent you is 0 at odd multiples of pi over 2. So that's why it skips. So that we have asymptotes. Okay, so let me show you really quick. So there's fiber 2. So we are approaching it, but never actually getting there. So every odd multiple that happens, it's undefined there. Okay. Anyway, so the main thing I want you to know is what does tangent look like? What does sine and cosine look like? Can you tell me what happens if I increase the amplitude? It just grows faster. It's not really an amplitude anymore, but case comes up, there it is. Now, if we were to double the angle, remember we said that corresponds to periods, right? It's hard to see here. But now it's repeating itself twice before, within its original period. You see that? Oh, this one repeated way over here, but now the green one repeats twice before it gets there. Okay. So same stuff as before, the sine and cosine. Anyway, any questions on these ideas? Can you find amplitude, period? Can you recognize what the function looks like if you saw a picture of it? That's all I really want. Just look at the graph and look at them. So for homework, just do 3 through 33 odd. This one will be pretty short. For the most part, it's just find those 3 things. They're called find those 3 things, and they might ask you to graph it, which you can use a grapher if you want. Maybe match a graph, stuff like that. Nothing crazy. So this homework should not take you more than it should be less than an hour, for sure. Anyway, any questions on 5.3 or 5.4? You guys have any questions on? So let's talk about 5.1 and 5.2. Have you any issues or concerns or problems? You guys able to find reference sets? Yes. No question?
We do a referencing question.
Yeah. Pick a random one from your homework. Let's do 30, I don't know. Reference points. 38, I guess. 5.1. find the reference. They call it number, but it's really an angle. For A, they give us an angle. Usually they use the notation theta. That's an ugly theta. Lowercase theta. 9 pi. Yeah, pre-cal likes to use a lot of Greek letters. And I don't know why, just how it is. Hopefully if you're in a sorority, you know what these letters are. Now, I don't expect you to memorize unit circle. I recommend you print it out and just always have it with you for exams or homework. If you want to get a tattoo, that's up to you. You can also try to memorize it, so it doesn't matter. Now, degrees and radians are the same thing. It's just a different form, like, you know, meters and feet. Who cares? So going from 0 to 180 is the same as going from 0 to pi. Okay. 0 to 360, meaning I'm going all the way to where I started, which is 2 pi, because that's 2 of these, right? Obviously. Or 2 times 180. Now, if I told you 9 pi, that would mean I had to go around the circle a few times, right? So how many, if you think about it, right, every 2 pi is a full circle. So how many 2 pi's are inside 9 pi?
Or
Yeah, right. So
Which one is it for? Because it was 3 answers. I just want to verify.
that's
I'm sorry.
no, you're right. You're right. You said 9 pi. So
You said 4 full.
how many 2 pi's go in there? You said yeah, 4, right? Sorry. So 4.5. So that's four full circles. So 4 times will land here again and again, right? So what really matters is that extra piece, that half. So I'm really landing here, right? If you count it the whole way, you can, like 1, 2, 3, all the way till 9. But really, what you really should do, you just divide out the full circles. So you could just keep subtracting 2 pi until you get to the remainder, or you could divide like we just did. So 9 pi divided by 2, or 9 divided by 2, right? 4.5. So 4 circles of just ending up in the same spot, so just disregard them. That half is what I care about. Where did I land? I land at a single pi. Okay. So the reference angle, that would be our answer then. Let's see. I feel like it should be 0 or pi, but 1 second. 5.1. So if you land right on there, it would be 0. That's true. So the thing about it, what is a reference angle? What we said on the video, I said,
your sample, the X after the terminal.
yeah, but we're right on the X. So what would be the reference? Yeah, so I would accept 0. A coterminal angle would be pi. But the reference, I believe, should be 0 because there's no distance to the x-axis here. So by the definition, reference should be 0. Just a really strange question. Shows.
So we should put it in degrees or 0.
It would technically be both. 0 degrees or 0 radians would be the same, right? But since they're talking in radians right now, when you see pi, that's not degrees, so you should assume that means radians. But radian is technically a unitless measure. Yeah, reference would be.
What if it was, I guess 10, and then it goes on to 2. Which way do we go, left or right?
On which one?
So let's say it was theta equals 10 pi, which would leave it on 3 pi 2, right?
If it was 10 pi,
Right.
that would leave us at 0.
Oh, 0.
Yeah.
Or, let's say it's 9.5, I guess. Whatever.
Yeah, as long as if we keep landing on the x-axis, it's gonna keep being 0.
Okay.
So we'd have to choose something that gets us away from 0 or pi. Like, I don't know, let's say we chose 5 pi fourths. Like, if we landed right here. What's that? 10. If we landed here. Let's say I went from 0 all the way to here.
Reference to B.
Yeah, would be what's the distance from here to here? That's what reference means.
Okay, well, what if it's like, what if there is no clear, short?
There will always be as long as I'm not on the axis.
So like, let's say right on the y-axis, though.
Like over
you
here?
Go either way, right?
Yeah, it would be 90 or pi over 2. So distance from here to there is the same. So reference would be pi over 2. That's a good question. Yeah, whenever you hear reference, just think, okay, well, where am I? And then figure out how far are you from the x-axis. That's all they're asking. And nothing else.
Can't see your paper.
Yeah, I'll switch in just a moment. So I would just say reference is 0 from 95. Part B, they say 5 pi over 4 or negative. So, where is that on our circle? Is that a known angle?
I think we should like add 2 pi to bring it to the circle. Negative.
Right there in the red. 225. Facing that
25.
negative.
Yeah,
What quadrant is that?
third quadrant, yeah. So it doesn't really, but it's negative, right? So we're not going all the way this way. We're going all the way over here. See what I mean? So change it to degrees if that's weird. 225 in this direction lands me here. 225 in the opposite direction. Where do I land? Right, it'd be 1, 2, 3 quadrants away. 1, 2, here, right? You guys agree with that?
Describe it again.
Yeah.
Well, let's think of the smaller angles first. 60 degrees is here, right?
Okay.
Negative 60 would be here, go in this direction. Negative means go clockwise. So the question on this problem said negative pi over 4. So we would be going to pi over 4, which is 225. It's really going negative 225. So negative 180 is right here. So 225 would be there. That makes sense? How far around the circle? Negative 225. Positive 225 is here. Negative is there. So what's the reference from that spot?
3 over 4.
Pi minus 3 over 4, 2 pi over 4.
Yeah. Pi over 4. So what we can do is what he was saying to show the work.
Is it gonna be a negative 3 pi over 4?
You would subtract to get the distance. So if I want to know how far we are to 1 to pi, to do pi minus that, you'll get that missing piece. So it would be positive pi. Reference angle will always be positive. I don't know if that was your question.
Yeah.
So yeah, just subtract. But you can also eyeball it most of the time. So if it's a known angle, you know where you landed, you can see how far you are. But if it's a strange angle, you may have to do this math here. Yeah, like let's say it wasn't, I don't know, let's make up a question. I'm gonna make up a new question. Let's say theta is 115. Right, that's not on the circle. It's not one of the special known angles. Right? The 115 is somewhere over here. So the distance from here to here would be 180 minus 115. So that gives you your reference. So the work to find it,
You can convert it to radians and apply to it, find the reference and radians. That's why convert the 115 to radians and then do the pi minus the number that we get.
yeah, you can do it in radians or degrees. I would stick to, if the question is in degrees, leave it degrees. If it's in radians, leave radians. Reference is going to be 65, 180 minus, yeah, I think you're right. Okay. So do you see what the reference angle means, right? It's just how far till the x.
So why is pi minus 3 pi over 4 equals pi over 4?
Oh, you'd have to do the LCD. Multiply by 4 over 4. You'll get a single pi 4.
Okay.
So earlier, so in the homework, they're also going to ask some terminal points, which is kind of what we were doing at the same time here. Terminal point meaning where do you land on the circle? So like earlier, the terminal point of 9 pi is actually pi, right? That's what they mean by terminal. Because they can give you some huge angle, but they're just spinning over and over again, and then finally they land somewhere. That's the terminal point. Okay. If you read the notes. A good thing to do to find coterminal angles or terminal points. If you see that the angle is really large, start by subtracting 360 or 2. Like for example, tell you what's the terminal point of 800 degrees. You're like, well, I don't know. Remove a couple of those circles or revolutions. So 800 minus 360, and 360 again. What would be left over? And that'd be 80 degrees, right? Because 360 is 720. So 800 would just be a little bit more. So I'd end up where I started, and then went 80 more degrees. So 800 is really the same as 80 degrees. So those are coterminal angles, the terminal point being 80. Okay? That's what they mean when you read the notes here. But we'll talk about coterminal more in the next chapter. So terminal point is kind of like a preview to that. Chapter 5 is a very basic introduction to the trig functions. We're going to hit it harder in chapter 6, not just yet. So 5.1, what I want you to know, or I want you to be able to do, is use a unit circle. Like if I tell you to find cosine of 90, can you do that? Sine of 45 degrees, can you do that? Right. So look at the circle. Sine refers to the y value. Right. Go back to it. Okay. Sine of 60 degrees. That means look at the y value. Cosine of 60 means look at the x value. So you would write down the half. Tangent means you divide them. Right? So make sure you know how to do that. So I look over the video, look over the section. Okay. I think, am I out of time already? Also, we're getting close to exam 2. I wanted it to be on Monday, but it's too soon because I've been away. So thinking earliest would be next Friday.
What's it gonna cover?
Chapter 5, and 4 and 5. Okay, so it'll be about logs. Make the majority, I think about 70% of the test will be log stuff. The last chunk will be some of this chapter 5 stuff. Okay. But we'll talk more about it when we start reviewing. So I'm thinking Friday we finish chapter 5, a return exam 1. Monday we start reviewing, and we'll figure it out from there. But I expect the earliest to be Friday. The exam will be next Friday on the 11th. Maybe the 14th, we'll see.
14th.
I guess it's gonna have to be 11 then. All right, it's gonna be 11. It's no choice. Because if I do after spring break, it's a horrible idea. But I did that one time and never again. Everybody fell because everybody partied on spring break.
What's that for?
12th is a Monday. Next week is the last week. And then spring break. See you later.